Hi guys, I'm Amy Shakila Bidadham and this is for my assignment 3 flight mechanic semester 2 2019 and 2020, and this is the data that I get from my sample case study that want me to find the theoretical minimum and maximum speed and also the rate of climb of the aircraft. First of all, we need to find the thrust available at 10,000 meter. From this equation, we can include the data power of density 10,000 meter divided by density at sea level and the power of m time with the thrust at sea level. For 2 engine, we need multiply by 2. And you get the answer. Next, we need to find the lift coefficient. First of all, we need to find the weight, which is mass times with the gravitational acceleration. And you get the answer 784,000 Newton. And you include this equation into this, which is weight divided by 1/2, which is 0.5, multiply with the density and multiply with the wing area. And you will get the answer, which is divided by v squared. Drag coefficient. From this equation, we know that the CDO is 0.02. And this one, we need to multiply the K with CL squared. K power of CL power of 2. And you will get the answer. Next, for the thrust required at 10,000 meter. Thrust required, you need to find the CD 1/2 rho v squared s. And this one that I get from the above equation, we need to multiply this one into this one. And 0.02 multiply with the 0.5, multiply with density and multiply with the wing area. And you will get the answer. For this part, we need to multiply this one into this one, which is this one, multiply with the 0.5, multiply with the density and multiply with the wing area. And you will get the answer, which is over v squared. For the last step, we need to calculate the R/C equation, which is that I get from the R/C equation. This one is TA that you get for the first step, and this one is TR, and this one TR also, and over the width, which is and finally you get the equation of R/C for this aircraft. Next, we need to answer the question, which is want me to find the minimum and maximum speed. First of all, I have create the table for the velocity, thrust required, and thrust available. The velocity is actually my data that 80, 10,000 and more, and thrust required is from this equation. You can get the thrust required for all and thrust available, this one. And next, we need to plot the graph to know the minimum and maximum velocity, which is the intersection of the graph can get the value for the minimum and maximum velocity. And actually we can find the intersection with TR equal to TA. And from this equation, we include the data, which is CD naught multiplied by S. And we get 2.6, and this one is TA. And this one is for KW. Done with power. W. Divide by S. And you will get the answer. And by this equation of quadratic, you can get for this one Q1 and Q2. And finally, you can get the V1 and V2, which is the last one is for the minimum and the bigger one is for the maximum velocity. Or you can get from the internet by using this web. I include the equation into that web, both equation, and I get the answer directly. Next is to find the maximum rate of climb. We plot the maximum rate climb from this data, and this equation is actually from this equation. And I select all the data, and this is the graph. To find the maximum, I max the data from this part until the last one, and I will get the answer is 13.6574 meter per second. And for the speed, V minimum, which is V2, and V maximum, which is V1. And this is the answer for the question.